Next part of our lecture is going to cover fraction rules. Now, fraction rules are a big thing because most people don't really care for fractions, and most people don't use them on a daily basis, so it's very easy to forget what the exact rules are. But you will get fractions in equations, and you need to know how to handle them. And in order to do that, you need to know their basic rules. The first rule that we're going to look at is simplifying fractions. Now, I know simplifying fractions is often something that people learn after they've learned, say, multiplying and dividing fractions, but in this case, we're going to talk about it first because it's something that we can actually shortcut later on. So we're going to see in a little bit here that there's a really good way to handle fractions and simplifying when you're dealing with multiplication. But for now, let's take a look at a typical fraction problem. Let's say something like 4/8. Now, 4/8 is a basic fraction here, but it's not the simplest way to express this fraction. And so what we need to do is we need to simplify. Now, when you simplify fractions, what you're basically doing is you are dividing the top and the bottom by a number you know goes exactly into them. Now, a lot of people see this, and the first thing they think of is, say, 2, because we know that 2 goes into even numbers exactly. And so if we divide both values by 2, what we get is 2 over 4. Now, the thing about simplifying is that once you get your initial answer, you have to check if there's something else that can go in even further. And one thing that sometimes people forget is that a number like 2 can be divided by itself. So it turns out you could divide this by 2 again. And that leaves you with 1 over 2, or a half. Now, some of you may have realized that not only can 4/8 be divided by 2, but there's actually another number. 4/8 can be divided by 4. So when you're simplifying, you do want to find the largest number possible, but as long as you can find numbers that you know can go into each value exactly, that is, no remainders, then what you'll see is that you should still get the same answer. So if you are working with someone or comparing answers, you should still both get a half in this particular case. So simplifying fractions is basically dividing the top and the bottom number by something you know goes exactly into this. Now, the best way to do this is just to know your multiplication very well. If you don't, then that's something you're going to have to review before you can really get the hang of this. So if you're having a hard time realizing what you can divide both fractions by, I strongly suggest that you go back and you review your multiplication because your multiplication tables are going to help speed this up a lot, okay? And a calculator can't tell you what the best number to divide by is. It's only going to do exactly what you tell it to do. So do bear that in mind as you work on these problems. So let's take a look at another type of fraction problem. Now, there's nothing wrong with dividing these one at a time by numbers you know. A couple of good tips to remember is that 2 can always go into every even number, 5s go into numbers that end in 5 or 0, etc., etc. But again, knowing your multiplication tables is the best way. But let's say that you just don't know off the top of your head what the best number is. Now, we can see here that for this particular problem, that for 48 over 42, we definitely could start with 2 and go from there. Now, there's nothing wrong with doing it that way, but another thing you can do is you do want to find the largest number possible. And so something you might want to try is focus on only one of the numbers. Okay, so let's say, for example, that I'm going to just look at the 48 and ask myself, what numbers do I know go exactly in the 48? Okay, so obviously 2, 4 works, 12 works, 6, 8, and that's about it, right? I mean, 48, of course, goes into itself as well, but what you want to do here is look at, okay, now that we have a list of numbers that we know go in the 48, do any of those go exactly in the 42? So obviously 2 does, but 4 doesn't. So 4 would not be something that we could divide both of these by, and you keep going. Okay, 6 works for 42, 7 works for 42, but beyond that, you're not seeing a whole lot. I mean, you have things like 21, but at that point, it's not going to work. So what we have found is that looking at these two numbers, the numbers that they have in common, right? The largest one is 6. So that's what we're going to want to divide by. So we're going to go ahead and divide each of these by 6. And if you know your tables, you can do this very quickly. But what you end up getting when you do that is that 48 divided by 6 is going to be 8, and 42 divided by 6 is 7. And so that's a good trick to use. If you're not sure what's the best option, ignore one of the numbers and ask yourself, okay, what are the different options for this guy? Then compare your options against the other one. The larger number is what you're going to want to divide by, and that's going to get you your answer more quickly. Some of you might have noted that I left this as an improper fraction. We will talk about that today, but you actually do want to leave it in this form. You don't have to turn it into a mixed number. If you have OCD and you have to turn it into a mixed number every time, well, this could have also be written as 1 and 1 over 7. But we're going to talk about why we actually don't want to use the mixed number format. We really want to keep it in the improper fraction form. Okay, so here I have a few problems I want you guys to try. We have 8 over 14, 63 over 36, and 35 over 56. So again, go ahead and pause your video at this point. In about 10 seconds, I will resume and give you guys the proper solutions. Okay, so in this case, what we're going to do is for the first one, we see 8 over 14. Now, because I see two even numbers, I'm going to immediately think 2 works for sure. Okay, and quickly checking this, there's not a whole lot of other options anyway, so we'll go ahead and divide both of these by 2. Now, going forward, because it gets a little bit messy to constantly be writing the division signs, instead of writing divided by 2, I'm instead going to cross it out, and I'll tell you guys that I divided by 2, and we'll leave it as 4 over 7. And what you'll find is that that will probably make it a lot cleaner on your notes. So just note that I did take out a 2 from here and left behind 4 and 7. So moving over to the next one, we have 63 and we have 36. Okay, now one thing in this case is notice they're not both even numbers, so we definitely can't take out a 2. Okay, the next thing often people try is they try 3 because it looks like this would work. Now, again, slow it down a bit. Realize that there might be other numbers that work as well. So looking at this, I'm going to use the technique that I mentioned last time. I'm going to look at 63. Whenever you have a choice, look at the odd numbers first because they typically have less options. So when I see 63, I immediately think, well, in that case, you have a 7 times 9. Okay, and so 7 and 9 work good for this. Obviously, 3 works. Comparing 36, I can see that, well, you got something like 6 times 6, but you also got something like 9 times 4. And so it turns out that our best option here is actually to take out 9. And so if we divide 63 by 9, we end up getting 7. And then if we divide 36 by 9, we end up getting 4. So that's something you can do is, again, try to find the best number. There would have been nothing wrong if you divided both of these by 3, and then later on you divide it by 3 again. That would give you the correct answer. but it's just a little bit faster. It's a little bit cleaner to do it this way. And then for the last one here, 35 and 56. In this case, what we're going to need to do is divide something that goes into both. 35 only has 7 and 5. 56 is 8 and 7. So because they both have 7 in common, let's go ahead and divide both by 7. That's going to leave us with a 5 over 8. So keep practicing that. Like I said, if you're a little bit shaky on that, you're not seeing quite how I'm finding those values, then what you want to do is go back and review your multiplication tables because this will greatly speed up the process. The next rule to talk about is multiplying fractions. Now, from here on out, instead of using the x for multiplication, we're going to use this dot here. The reason for that, of course, is that in an algebra class, typically x is used for our variable, and we don't want to have confusion between multiplication and variable. So from now on, we're going to use a dot. Now, in this case, what we have is 3/8 over 7/4. Now, multiplying fractions is the simplest rule, and the way you handle it is you simply go straight across the top, straight across the bottom. That's it, no frills. It is that simple. So we multiply across. 3 times 7 is our 21. 8 times 4 is 32. Now, related to the last subject we talked about, simplifying, you would check these to see if you can simplify. But it turns out that nothing goes into both 21 and 32 exactly. Okay, because, well, only 3 and 7 work for 21, and neither of those work great for 32. So overall, multiplying fractions are not too bad. In fact, this is the simplest rule, and we're going to see that there's a few other things that we can learn while we use this method. Now, in this next problem, we run into a bit of an issue. So here's the thing. Sometimes when you're multiplying, you get numbers that you really would rather not multiply if you had the choice. But of course, in this case, we have to do it. So you can still multiply straight across like we just did in the previous problem. So we have 10 times the 21. Well, that's going to give us 210. Okay. And then, of course, we're going to take the 21 and we're going to multiply it by the 25. And that gives you 525. Don't worry, I don't expect you guys to do it that quickly off the top of your head. So here's the issue. We can see here that we're going to have to simplify. And for one thing, it would normally be difficult to check. Now, we're fortunate here because this one ends in 0 and this one ends in 5. So that's a clear sign that we should divide by 5. But this is going to be a long process. It's going to be a multi-step simplifying type problem. We're going to simplify. We're going to find out that that's not going to be good enough. We'll have to simplify again. And most people would actually probably take 3 steps to do this problem the way it's written. Now, there'd be nothing wrong with doing it that way. It's just, again, you really don't want to do it the long way if you can help it. Now, I'm going to do a little bit of a spoiler here, but the correct answer for this ends up being 2/5. Right? And that's because the first time you could take out a 5. I'm not going to show all the steps here, but after you take out a 5, a lot of people see that you can take out a 3, and then they notice, oh, wait, I could also take it out a 7. Now, you could do these in any order. They'll still give you 2/5. So how can we speed up this process? Because this takes a little bit longer than we would normally want. Well, there is a trick that only works when you're multiplying fractions. Okay, and I want you guys to note this down, is that this trick only works for multiplying fractions. So what you can do is it turns out that the order of multiplication doesn't actually change your answer. So let me demonstrate what I mean. Okay, let's say hypothetically what I do is I take the top two numbers and I change the order. Now here's the thing, 10 times 21 or 21 times 10 both give you 210. So that shouldn't change the answer I get, right? So let's just swap them. Let's move the 21 over to the first fraction. So we get 21 over 21. And let's move the 10 over to the second fraction. And of course, that gives us 10 over 25. Now, some of you might notice here that both of these fractions are now something that we can simplify before we multiply, right? 21 goes exactly into itself, so that would leave us with just 1 over 1. And if you look at 10 and 25, well, they both have 5 in common. So we'll take a 5 out of both of those to leave us with 2 over 5. Now you'll notice that gives us an answer of 2/5. So it turns out that this is a lot easier than working through step by step the way we did before. It's actually going to cancel out earlier. Now, in a typical problem, you wouldn't actually have to swap the top numbers. If you want to do that, you can. Okay, there's nothing wrong with taking this and rewriting it as this. But what's actually easier is realizing that the rule is simplified by the following phrase. As long as a number can divide into the top and the bottom of a fraction in multiplication, then you can simplify immediately. And so going back to the original problem here, I don't have to actually look at 10 over 21 and 20 over 25. I can look at 10 and look across at the 25. So I can see here that 10 and 25 both have 5 in common. As long as one is on top and one is on bottom, I am allowed to simplify that immediately. And when I do that, just like before, this 10 becomes a 2, and this 25 becomes a 5. And again, for the same reasons, 21 and 21 both go into each other exactly. So if I divide both of them by 21, as long as it's top and bottom, I am allowed to do this. And so what we get by doing that is 2 times 1, which is 2, and 1 times 5, which is 5, so we get 2/5. So this is a very handy shortcut that you want to use because it's going to make your life a lot easier. Now, we run into a problem when we're dealing with mixed numbers. Okay, so mixed numbers are these guys here. They're when you have a whole number and a fraction as part of a single expression. Now, when you get something like this, you cannot just simply multiply across. A lot of people think, oh, well, I can just multiply these two things together. I can take the 4 times the 1, and that gives me 4. And then I can multiply these across. 2 times 7 is 14. 5 times 8 is 40. And they say, okay, yeah, I got to simplify that, but this is going to be my answer here. And that turns out to be completely incorrect. Do not do that. Okay, you cannot do this when you have mixed numbers. Okay, so the question is, well, what do we do instead? Now, what we want to do is go ahead and work with these as improper fractions instead. So we don't want them to be in their mixed number forms. So in order to do this right, what we're going to need to do is actually go through a multi-step process. Okay, so the first step is what we have to do is turn this into an improper fraction by taking the whole number value and multiplying it by the bottom value. So what we do is we go ahead and we take the 4 and the 5, and we multiply them together. So we get 4 times 5, which is simply 20. Now, the second thing we're going to do here is we now take this value and we add it to the top number of the fraction. So we take that 2 and we move it all the way down here. So we get 20 plus 2, that's going to give us 22. This number is going to be the top part of our improper fraction. So what we're going to do is we take that 22, and originally the bottom number was 5, so we keep it that way. This is now 22 over 5. So we do something similar with the next one. Okay. Now the next one is pretty simple here because we're dealing with 1. So you take the 1 and you multiply it with the 8. So I know this seems obvious and a waste of time, but I do like to show all my steps. And now we have 8. And since we have 8, again, what we're going to do is you take that result and you add it to the top value, which we had as 7. So that gives us 15. And so what we have now is a fraction that is 15, and it's going to be over 8. So again, hopefully you're going to see that if you simplify early, I can't stress how important this is. You want to simplify your fractions early because it's a lot easier to go ahead and continue from here. Because what we can do is realize that both 5 and 15 have 5 in common. So we'll cancel those out to leave a 1 down here and a 3 up here. And then 22 and 8 both have 2 in common. So that cancels out, becomes a 4. And this cancels out and leaves 11. So what we are left with is 11 times 3, which is 33, and 1 times 4, which is simply 4. And that's the answer you want to have. Now again, some of you might prefer to write them as mixed numbers. I'm not going to make anyone do it, so I'm not actually going to walk through how that works. The book does talk about it if you are interested, but honestly, it's in your best interest to leave it as 33 over 4. So if you do prefer, though, to write it as a mixed number, what you're going to get is 8 and 1/4. Again, both of these answers are identical, so as long as you get one of them, you would have the correct answer. Okay, so here are the practice problems I want you guys to do for multiplying. Now, for these, remember, you can simplify early, but you still go straight across the top, straight across the bottom as a basic level. For the mixed numbers, you need to turn them into improper fractions first. Then, from there, you can multiply straight across like you normally would. So, go ahead and begin those problems. Pause the video now, and we will resume in another 10 seconds. Okay, so the first one, what we're going to do is we're going to check to see if we can simplify first. Now, there isn't anything in common with the top or the bottom of either fraction. So because that's the case, what we can do here is simply go across the top and bottom like we normally would. So pretty easy there. So that gives us 4 over 45. So moving on to the next one. These look like larger numbers, so we definitely want to check if there's anything in common. First thing here, notice 8 and 32. A lot of people see 2, but don't forget you want to find the largest number. It turns out that 8 does go exactly into 32. So let's go ahead and take out a full 8 to leave 1 and 4. Over here, 15 and 25, what we do is we take out a 5 to be left with 3 and 5. Last thing, go across the top, we get 3. Go across the bottom, we get 20. Okay, so far so good. For the last one, we're going to have to change them. Now, I'm going to illustrate or kind of talk about each step individually, but I'm not going to necessarily show everything here. Um, so remember, you do 3 times 4, that would give us 12, and then plus the top number, which is 3. So this problem ends up becoming 15 over 4. 2 times 3 is 6, and then 6 plus 2, that's going to give us, for the second one, 8 over 3. All right, you guys know the drill by now. We can go ahead and simplify before we go through and multiply. So 4 goes exactly into 8. And 3 goes exactly into 15. And we multiply across, and we get 10. Or some people might write it as 10 over 1, but that's the same thing. And we'll actually talk about why that can be helpful sometimes. But those would be your examples for these. So that is going to be the end of this video. In the next one, what we're going to do is we're going to talk about the dividing and adding rules for fractions. And we'll see that there we got to make some modifications because it doesn't work quite as easily as these ones.